Hello and welcome students. This is a lecture on differentiation and we are doing nth order derivatives. In last video on this, I had find out, see the earlier two videos on nth order derivative. In first one, we got the nth order derivative of y equals to x raised to m, that is variable raised to constant function. This is also known as power function. We got the nth order derivative of this. Then I solved for you the nth order derivative of ax plus b raised to m. I solved for you this one. And the only difference that you found was in this when you differentiated. See, when you differentiated this with respect to x, it was d by dx of x raised to m. But when you were differentiating this every time, it was d by dx of ax plus b raised to m. So what happened? This was f of x raised to m. So after you apply the result, you also had to differentiate ax plus b. So every single time you differentiated, you got this a. You got this a. That is why in the answer you got a raised to m. If you remember, the answer that you had got a raised to m there. I'll show this to you. See, this every time you differentiate, see you got this a. And once again you are getting a, so a square. Then a cube. You see this? Then a raised to 4. So this is what happened. Anyways, so you can see those two videos and you will understand it. But what I'm going to tell you now is I'm going to take the see. I will now take for you. I will take for you the nth derivative of y equals to 1 upon x. This is reciprocal function y equals to 1 upon x. You know its derivative, the first derivative is y. If y is 1 upon x, then you know dy by dx is minus 1 upon x squared. But I don't want first derivative. I want nth derivative so that I could find any derivative, any. Okay. So I will find the nth derivative of 1 upon x, using which you could all find the nth derivative of 1 upon ax plus b. You can find derivative of nth derivative of 1 upon ax plus b. So I will find this. You will all find nth derivative of this. The technique will be same. See, as using this, you found the nth derivative of this. Here using this, we will find the nth derivative of this. So let us begin with it. So I am starting with the nth derivative of y equals to 1 upon x. And this is actually the second question from exercise 1.5, fourth second. So I write here exercise 1.5 from derivative topic, question number 4 and second. It is y equals to 1 upon x. What I will do here is, see students, I will differentiate for the first time, right? So differentiating with respect to x, I will get d by dx of y equals to d by dx of 1 upon x. Now you all know derivative of 1 upon x is minus 1 upon x squared. So you got dy by dx is equal to minus 1 upon x squared. Okay. This minus 1 upon x squared is first derivative. I will differentiate this once again. You know we have to differentiate it 3-4 times so that we get a pattern. And once we get the pattern, we write the nth order derivative. That is the idea. So I differentiate with respect to x. So I will get d by dx of dy by dx. So it will become d2y by dx2. I'm sure you all know this. And here I have d by dx of minus 1 upon x squared. Okay. Now see students, this minus 1 is a constant. So this minus 1 you will write out, and once minus 1 is out, what you are left with? You are left with d by dx of x raised to minus 2. See, this is 1 upon x squared. So in order to differentiate, what I will do, I take this x square in the numerator, so it becomes x raised to minus 2. And what about this negative 1? This negative 1 I have written out, right? So now I differentiate. Now I differentiate this. So I will get here So I get here, therefore, d2y by dx2 is, see, negative 1. And you all know what is derivative of x raised to minus 2. It is minus 2 x raised to minus 3. This is second order derivative. I differentiated once again, differentiating with respect to x. So you will get d3y upon dx3. And what will it be? Minus 1 minus 2, and derivative of x raised to minus 3 is minus 3 x raised to minus 4. Minus 3 x raised to minus 4. Let me differentiate once more. So when I differentiate once more, so I'll get d4y upon dx4. And what is that? It is minus 1 minus 2. It is minus 1 minus 2 minus 3 minus 4 x raised to minus 5, and that is all. See, this is here first derivative. This is here first derivative. I can write it as minus 1 into x raised to minus 2. See, this is first derivative. Minus 1 upon x square, I prefer to write it this way. Okay. Now here I have second derivative. Second derivative. Look at the second derivative. In first derivative, what you have, students, check. dy by dx is minus 1 upon x square, which I write minus 1 into x raised to minus 2. Here I have second derivative. I will write it as, see, how do I prefer writing? You will all agree that we got a negative 1 here, we got a negative 1 here, and a negative 1 here. Yes. This negative 2, please understand that this negative 2 is negative 1 into 2. So I can always say that there is a negative 1 here and there is a negative 1 here also, negative 1 into 2. So for the second order derivative, see what I will do. For second order derivative, I write it as, see, I write it as minus 1, I write this as minus 1 square. How minus 1 square? Because I have minus 1 and minus 1. So minus 1 square and 1 into 2, 1, 2, and x raised to minus 3. This is my second derivative. Now come to third derivative. See, for third derivative, I will prefer writing minus 1, minus 1, minus 1. So there are 3 minus 1. So minus 1 cube and 1 into 2 into 3. Okay, 1 into 2 into 3. 1 into 2 into 3. and here you have x raised to minus 4. Got that? And see the fourth derivative, I will have here minus 1, minus 1, minus 1, minus 1. There are 4 minus 1. So minus 1 raised to 4 and 1 into 2 into 3 into 4 into x raised to minus 5. Okay. So this way, if I continue, what I understand here is, students, if I continue this way, what I understand that dny upon dxn, that is nth order derivative. See, for the first derivative, I have minus 1 raised to 1. Minus 1 raised to 1 I have. Okay. For the second order derivative, I have minus 1 square. What do I have? I have minus 1 square. See, here you have second order, so here you have minus 1 power 2. Third order derivative, you have minus 1 power 3. Fourth order, you have minus 1 power 4. So what I understand is that nth order, I'll have minus 1 power n. Further, if you check, see, when you have the first order derivative, then see, it is minus 1 into 1. Here you have 1. You see this? Minus 1 into 1 you have here. Though that 1 is not visible, it is okay. Even if you are not writing. See, you have 1 here. Minus 1 into 1. Here what you have? You have minus 1 square into 1 into 2. See, for second order derivative, you have 1 into 2. For third order derivative, you have 1 into 2 into 3. For fourth order, 1 into 2 into 3 into 4. So this way, if I continue, I understand that for nth order derivative, I'll have 1 into 2 into 3 into 4 like this up to n, multiplied up to n. And then finally, x raised to, see, when it is fourth order derivative, you have x power negative 5. That is negatively 1 more than this. You're getting? See, when you have first derivative, first order, this is d1y upon dx1. When you have first order derivative, what do you have? You have x raised to minus 2. So can I say it is negative and then 1 more than the number here? Yes, if you have 1 here, then this is negative 2. Then here, see, second order derivative, so what is it? It is negative 2 plus 1. Here you have 2 and this is negative 3. So it is negative 2 plus 1. What is this? It is negative 3 plus 1, third order derivative. So x power is negative 3 plus 1. X power is negative 3 plus 1. Fourth order derivative, x power is negative 4 plus 1. So if it is nth order derivative, it is negative n plus 1. It is negative n plus 1. This is the nth order derivative. So in next step, what I am going to do is, see, I will now see in the next step, what I will do is, I will write therefore dny upon dxn is equal to minus 1 raised to n into n factorial. You can check very well, it is n factorial from here to here. Divide by x raised to n plus 1. This is the answer. Divide by x raised to n plus 1. So using this, see, we got the nth order derivative of y equals to 1 upon x. When you will have to find the nth order derivative of, when you will have to find the nth order derivative of 1 upon ax plus b, what will you do? See, now homework for you. Y equal to 1 upon ax plus b. I think it is not visible that bright. So let me take another pen. Okay. You have to get now y equal to 1 upon ax plus b. You have to get the derivative of this. So what will be the first derivative here? Dy by dx, you will get minus 1 upon ax plus b the whole square, right? What you will do next? See, minus 1 upon x square you got. Here you will get minus 1 upon ax plus b whole square into d by dx of ax plus b. Remember, it is not 1 upon x, it is 1 upon f of x. It is 1 upon f of x. Every time you differentiate, you will have to write derivative of ax plus b, which is a. So here you have a. Okay. So since you will get this a every time, so nth order derivative, remember, in nth order derivative, you will have a raised to n. You will have a raised to n. You will also have minus 1 raised to n. You will also have minus 1 raised to n. You will also have n factorial. Yes, you will have n factorial. And down here, you will have ax plus b raised to n plus 1. This you have to, this all you have to do. Students, this is going to be the nth order derivative of 1 upon ax plus b. You will see I have done 1 upon x for you. You will follow the same technique, okay, and you will go for this. For taking help, what you can do is you can check how in the previous video you can check how I have done ax plus b raised to m. Okay, you can do that.